All right, so here's the rest of 7-1. There are a lot of trig identities, as you can see. Now, these reciprocal identities we talked about before. We've talked about the quotient identities. Here are the Pythagorean identities. These are the main ones that we're going to focus on for a short time. Right now, we're going to talk about simplifying. Simplify the expression. So if I give you an expression such as this one, we're going to say cosecant x minus cosine x cotangent x. That means times cotangent. So even though it's not there, it's implied multiplication. Now when I see equations like this, I don't freak out. I automatically go straight for my reciprocal identities. So I look here. And I say, is there anything here that I can switch? Now, ultimately, I want to keep things in terms of sine or cosine or tangent normally. So I see cosecant, and I'm like, whoa, cosecant's the same as 1 over sine. So I'm just going to change that to 1 over sine. I'm also going to drop the x out because that's just the angle. It's kind of unimportant right now. Cosine's already in cosine, so I'm going to leave cosine alone, and I'm still going to get rid of that x because I'm getting lazy as I work through the problem. Now cotangent is a quotient identity, so I'm going to rewrite cotangent in terms of cosine and sine. So that's going to be cosine times cosine over sine. At this point, I'm like, ooh, I see something I might be able to do. I've got 1 over sine minus cosine times cosine is cosine squared over sine. And then I see, oh, they're fractions. They have a common denominator. I can write it as a single fraction. So this is 1 minus cosine squared over sine. At this point, I'm going, all right, now what do I see? I see squared things. Anytime I see something squared, so I've got this cosine squared. And so I have that cosine squared, so I'm going to go to my Pythagorean identities. So anytime you see something squared, you go to your Pythagorean identities. Well, the one that has cosine squared in it is the first one listed right here. It's got cosine squared in it. So I'm going to just kind of off to the side here, I'm going to look at this. I got sine squared plus cosine squared equals 1. So I'm like, well, what if I can manipulate this. I can subtract cosine, and so that's going to be sine squared equals 1 minus cosine squared. Oh yeah, 1 minus cosine squared. I can replace it. So 1 minus cosine squared equals sine squared over sine. So sine squared over sine, that I can simplify. Sine's going to cancel with one of these signs, and my final answer is going to be sine x. Final answer. That's one simplification problem. Okay, now I've got a few of these planned. So number 2 here, I've got sine x plus sine x times cotangent squared x. And on this one, I look at this and I'm like, well, I see sine x and sine x. I'm going, well, what's my favorite F word? I want to factor that sine x, so that's what I'm going to do. I'm going to factor a sine. Sine divided by sine is 1. Plus this crazy thing divided by sine is going to leave me with cotangent squared x. And then I'm going, I see some squared things, and I'm going to go back and I'm going to look at those Pythagorean identities. Well, 1 plus cotangent squared, that's this third one right here. What does it equal? I don't even need to manipulate it. That identity itself is sine times, I'm sorry, I got distracted by my own silliness. Sine times cosecant squared. Well, now I've got cosecant squared. Well, how else can I write cosecant squared? Well, cosecant is the reciprocal to sine. So this is going to be sine times 1 over sine squared. And one sine will cancel with that, and I'm going to be left with 1 over sine, which is equal to cosecant. And now I'm going to get unlazy and put that x back in there. Final answer. Next problem. I'm distracted by those circles that are coming with this program thing. Oh well. Number 3. Number 3, we're going to look at secant x over tangent, not tax, tangent x. All right. Now with this one, again, I'm going to rewrite secant using sine and cosine. So secant is the reciprocal to cosine. So this is 1 over cosine. Over, and then tangent using a quotient identity. Tangent is sine over cosine. And then here we have a complex fraction where we're going to keep the top, change to multiply, and flip the bottom. Keep, change, flip. I love that phrase. So when we keep, change, flip, it's going to be 1 over cosine because we keep the top. Make it a multiplication problem and flip the bottom, cosine over sine. And look, we've got a cosine on the bottom and a cosine on the top. They cancel each other out, leaving us with just 1 over sine. Well, 1 over sine, according to our reciprocal identities, happens to be cosecant. Final answer. The last example I'm going to do, and I'm going to grab this identity sheet and bring it down here. For some reason those circles are coming with it. That's fun. Number 4. What happened there? Anywho. Number 4. This one is going to be sine x cosine x times secant x and times cotangent x. All right. Now, x's can be exchanged for other variables like theta. So you might see problems later where they're using theta. Okay. So keep that in mind. I just used x this time. Now that's a sine, that's a cosine. I'm going to leave them alone. And I'm going to go to this secant and cotangent. And I'm going to say, all right, so I got sine x. We can drop off the x in the middle. So I got sine times cosine times 1 over secant's the reciprocal to cosine. Oh, looky there. Times cotangent, which is, according to the quotient identity, cosine over sine. All right, so anything on top, now these are all over 1, so keep that in mind. So anything on top exactly the same as the bottom will cancel at a 1-to-1 ratio, so those cosines will cancel. And this sine's on the bottom and that sine's on the top. That cancels. What are we left with? We are left with cosine x. Okay, good luck. This is important to know how to do.